So we're going to be talking about integration by parts. Integration by parts is a method of solving integrals that you don't automatically know the answer to, and that are in the form of two functions being multiplied by each other. So if you have like an integral and you can see that there's two different functions and they're being multiplied by each other, you know to use this method of integration by parts. And the formula for integration by parts is the integral of u dv equals uv minus the integral of v du. So I know that kind of seems like a bunch of letters, so I always try to simplify it. You basically have to find out what your u and your dv is to begin with. And there's a simple formula for figuring out what your u is. It's called ILATE. ILATE stands for inverse, logarithmic, algebraic, trig, and exponential. So it's basically kind of like in order way of finding out what you should set as your u. So if you see your two functions and you see one of them is inverse, the inverse function is automatically going to be your u, and the dv function is going to be with the other function. And logarithmic would be the second top choice, algebraic, trig, and exponential, and it goes in that order. So we can go ahead and start doing an example problem. And an example problem for integration by parts could be the integral of 3x times e to the negative 3x dx. So when you automatically look at this problem, one thing comes to my mind automatically. To simplify it, you can go ahead and factor out your 3 to the outside because it is a constant. And since as a constant, you can move it to the outside of the integral, and that'll probably make solving the integral a lot easier. So if you move the 3 to the outside, you just have x times e to the negative 3x dx. So you're looking at the problem, and you can tell that you have two functions being multiplied by each other, x times e to the negative 3x. So you go here to ILATE, you look down your list, you try to see which one of these functions is one of the ILATEs. X happens to be an algebraic function, so you automatically know to set x as your u. And that would mean that e to the negative 3x is your dv. So once you have your u and your dv, go ahead and set them equal here. U equals x, and dv equals e to the negative 3x. So you know what your u is and you know what your dv is. So now that you know what those are, you can go ahead and find out where your du and your v is. So du, which is just the derivative of u, is going to be equal to 1 because the derivative of x is just 1. And dv, v is going to be equal to the integral of e to the negative 3x. So all you have to do is solve the integral of that, and that's an integral you can solve. So the integral of that would be negative 1/3 e to the negative 3x. Because you know the integral of e to the x is just e to the x. And then you have to also get the integral of you have to be able to solve the inside function as well. So when you take the derivative of negative 1/3 e to the negative 3x, you're going to first take the derivative of the outside function, which is just e to the negative 3x. And so you'll automatically have e to the negative 3x, and then you'll have the derivative of the inside function, which is negative 3. Negative 3 times negative 1/3 equals 1, which would just then be e to the 1 times e to the negative 3x. So you know that that's your integral. Once you have that, you start plugging this into your formula of the integral of u dv equals uv minus the integral of v du. So you come down and you say, alright, the integral of u dv is going to be equal to uv x times negative 1/3 e to the negative 3x. So to make that simpler writing, you can just do this, x times e to the negative 3x. Oh, and don't forget to put a 3 on the outside. Make that look prettier. Because this, you are multiplying the whole thing by the 3. So you put a 3 on the outside. So it's 3 times uv x times negative 1/3 e to the negative 3x minus the integral of v du. The v du. And your v is negative 1/3 e to the negative 3x and your du is just 1. So basically this is going to be this. This is a constant, so you can go ahead and put that on the outside of the integral. So you can change the minus to a plus, since it's negative, negative, that equals positive. Put the 1/3 on the outside, and say the integral of e to the negative 3x. So, now that you have this equation, you know how to solve this. So, you go back and you're looking at it, and you're saying, okay, I know what the integral of e to the negative 3x is because I just solved it right there. So you can go ahead and simplify this even further. Go ahead and write it as the integral of 3x e to the negative 3x is equal to 3 times the quantity of negative 1/3 x e to the negative 3x plus 1/3 times the quantity of negative 1/3 e to the negative 3x. And again, you know this integral because you just solved it up here. So, after you have that, you can go ahead and simplify this further and make it a little bit more. That's basically the answer. And you can simplify it a little further. Go ahead and multiply the 1/3 out, and you're going to get negative 1/9 e to the negative 3x. And then you can multiply your 3 out to both of these, and you will get a final answer of 3 times negative 1/3 is just going to be negative 1 for negative x e to the negative 3x plus, again, that was multiplied out to be negative 1/9 times 3 would just be negative 1/3. So minus 1/3 e to the negative 3x. And that would be your final answer. So the integral of 3x times e to the negative 3x equals negative x times e to the negative 3x minus 1/3 e to the negative 3x. Okay, quick recap of what we did. We found out the formula for integration by parts is the integral of u dv equals uv minus the integral of v du. And you know to recognize an integration by parts whenever you have two functions, like you have here 3x and e to the negative 3x being multiplied together. So there's two separate functions. The next step is to identify where your u and your dv is. Your u, and you do that by finding out where your u is, and you do that by looking at ILATE, which stands for inverse, logarithmic, algebraic, trig, and exponential. And the problem we had in x, which is an algebraic function, so that would be our u, because that comes before e to the negative 3x, which is an exponential function. So our u is x, and our dv is negative 3x. We set u is x, and dv is e to the negative 3x. And we can find out what du and v is by solving what the derivative of x is, which is 1. And by solving what the integral of e to the negative 3x is, which is negative 1/3 e to the negative 3x. We then plug those numbers into the formula that we have up here, and we get 3, because we moved the 3 out because it was a constant, times the quantity of negative 1/3 x e to the negative 3x, because that is u times v, plus 1/3 times the integral of e to the negative 3x, because that would be the minus the integral of v du. After that, we can't just leave an integral in the answer, so we have to solve for that. So we go down here, and we, again, basically copy down the front half of it, saying 3 times the quantity of negative 1/3 x e to the negative 3x plus 1/3, because you're multiplying 1/3 by the integral of this, the answer of this integral. And the answer of that integral is negative 1/3 e to the negative 3x. And we knew that because we solved it again up here. So after that, we just simplified it down to make it easier to read. And we got a final answer of negative x e to the negative 3x minus 1/3 e to the negative 3x. And that is a simple way of trying to do integration by parts.